That's for the basic communication. There are some variations here. Like for example, as we can see here, a dotted arrow, and here we have a solid arrow. The question is, why is that the case? Well, the dotted one, there we have the case that the state holder, in this case the qubit, it has a stream. When it has a new state, it puts the state inside the stream, then anyone who wants can listen to that. In our case, it's the UI. But the UI can just listen to the stream, and whenever there's something new, it can take this new element and display it. So the UI doesn't have to poll the qubit every, 5 seconds, like, do you have something new, do you have something new, and so on. It just listens to the stream, and that's it. So now the question is, how could we do this? Like in the end, we also want to have a dotted line here. So let's see, how can we do this? Yeah, hello everybody. Thank you for having me. So welcome to my talk with the super short title, Unlocking Flutter Success, a Journey from Theory to Practical Architecture. Maybe first things about myself. So I'm a software engineer at Arconsis IT Solutions, a software house based in Karlsruhe in Germany. I'm also from Germany, which you can probably hear by my accent. I started trying out Flutter in university, and my first real project as a full-time employee was actually also a Flutter project, and I have grown to love it ever since. Aside from that, I'm also holding a lecture at one of the universities in Karlsruhe about app programming. And aside from that, a little side note, I like to build and collect Lego, so if anyone wants to network on that, definitely hit me up. Now, what is this presentation about? So let me maybe start with a little anecdote. Back when I started with this big first project, one of the more experienced colleagues came to me and he asked me, what architecture do I want to use? And then I just said, I think there is this BLoc library, I think I can use, that should do it. And then he said, that's not what he meant. It's not about just using a library that's maybe fitting in one part of my app. It's more about what structure do I want to have in my app, how should the data flow, what components do I want to have, and so on, which is way bigger than just one library. Of course, having libraries is fine, probably also multiple ones, but it's much, much more to it than just that. So if we are now talking about architecture, maybe one of the first things to do is to define a little bit what is architecture. And I have this little definition here for you. Software architecture defines the components, relations, and properties of a program. At least that is what ChatGPT told me when I asked it. And interestingly, it just copied this answer from Wikipedia. So yeah, what a time to be alive. But actually, I have to say, I like this definition quite nice, maybe putting it in my own words. Software architecture is about the components that we have, their properties, the purpose that they have, and how they communicate with each other. And now we have a little problem, because in Flutter, there's not really an overall guideline on what architecture to use. Of course, there is some information about state management. We've also heard some super nice talks about that, but not really about an overall architecture. And now the question is, what can we use here? How can we have our components and put this all together? And now the thing is, why should we reinvent the wheel if we could just use something that's already there? And if you may know, Google is not only doing Flutter, they are only also providing the Android open source project. And for that, they actually have some extensive guidelines on how to do an architecture. And they call it the recommended architecture for Android apps. And don't worry, we will completely stay in the Flutter and Dart world today. But this recommended architecture is so generic that we can easily adapt it to Flutter and then use all the principles that we have in there to have our own scalable, maintainable, and growable architecture. And in the end, all of that is just a recommendation. So we can take this architecture, we can extend it, we can replace some parts as we like. Again, all just some recommendations. So maybe in some short words, what do we have here? As you can see, it's a layered architecture. The arrows describe which components depend on another one or use a lower one. And so yeah, principle of a layered architecture, as in all layered architecture, you have one layer and it provides functionality to upper layers, which then can use this, but you don't do it in the other way around. A lower layer should never use something in the upper layer and never know what's there. And aside from that, we also have separations of concerns, quite interesting and important. So inside our components, we pretty much have only one purpose or a small set of some purposes. That as an overview, maybe now head inside the components to see what their purpose is. So we are starting from the bottom to the top, and the first component is our data sources. Our data sources, they hold the application data. We can also say our single source of truth. If any part of the application needs this data, it eventually needs to be get from here, or if you want to change it, it needs to be altered inside the data sources. This can have several variations, like the classic ones could be a network where we get some data from, or a database, but also some others like a file, or also some just in-memory cache, something like that. And most of the time, these data sources provide basic CRUD functionality like create, read, update, and delete their data, and yeah, pretty much the classics. After that, we have our repositories, and a repository contains the business logic for one certain data type. For example, let's assume we have an app which can display movies and TV series and artists and so on. Then, for example, we could have a repository that handles the type movie. It would hold all its business logic on how to get it, how to alter it in the end, and so on. And of course, to do this, it needs the data sources which provide this data, in this case, the movie data. And in the end, it then exposes this application data to the upper components. Then just quickly, the domain layer. We will see an example later. It's pretty much optional in this whole architecture. Its main purpose is to reduce the code in the repository or inside the stakeholder, which we will see soon. We will see an example for that later, but it's mainly optional and most of the time not needed in the first place. Now we can head on to the stakeholders. We are now in the UI layer, and the purpose of a stakeholder is to get all the needed data for a specific UI it's serving for. And for that, it gets all the data, transforms it in a UI state. We've also seen that in the BLoc library, and then provides it to whoever needs it. And in the end, it can also listen to some events that are at first triggered in the UI. And now the last element, or the last component, these are the UI elements. These are our widget as we know them inside our screens. They consume this UI state, build the UI based on them, and then in the end, when something is happening, it fires or it submits the event to the stakeholder again. So now we have seen in a basic and theoretical way what components we would have inside this recommended architecture and what their purpose is in a basic way. The question is now still, how would these components communicate with each other? And for that, let's assume we would have, as I just said, some sort of a simple movie app where we can display a list of popular movies, like the ones that are currently in trend. And let's assume we can load them from some backend, and we can only load them in pages. Like if we do a backend call, we can only get 20 movie elements, like not the whole list, because it would be way too much elements at once. So we can only load 20 elements, and then the next 20, and so on, in pages as we need them. And now let's see how the communication is done and how we can also actually apply them in code inside Flutter and Dart. So we again starting from the bottom to the top, and we're starting with our data source. So here we have a data source called a movie RP. This is where we are getting our list of movies for the popular movies list. As you can see, here I'm using the library RetroFit. It's a library to allow me to use some annotations. In the end, it will generate all the boilerplate code needed to have a fully fledged HTTP client. So what is this data source doing? Well, it's pretty simple. We just have a function to get this list of popular movies. Again, it's a list of 20 elements based on the page we're accessing. And we are here returning an element of type popular movies page, DTO. And inside that, we just imagine is our list of movie DTOs. DTOs is short for data transfer object. I will use this inside the network areas. We will shortly see why and what we will also use. But for now, let's take this data source. So to sum it all up, we have our data source with our list of movie DTOs. That's the first step. Now, we're heading inside the next component, which would be a movie repository. Again, this is a repository that handles the data type movies, the business logic, and so on. So what is this class doing? First of all, it holds the data source it needs to get the movies, in this case the movie RP, the class we've just seen. And as you can also see, I'm using dependency injection, in this case injectable in combination with getIt, so that inside my classes I only have to state the dependency, but I don't have to care about how this class is instantiated and how for example, the movie RP is passed inside the movie repository. This will all be done by the dependency injection, and I use it throughout the whole architecture. So what is this repository now doing? As we can see, it also has just one simple method to get the list of popular movies. So what are we doing? At first, from our API, we are getting the list of movie DTOs. And then, in a second step, we are accessing these and we transfer them to a list of movies. So from a list of movie DTO to a list of movies. Why are we doing this? Let's have a short look inside both of these classes. On the left, the DTO, on the right, the normal class. Both of them have pretty much the same class variables. As you can see, some ID, title, poster path, everything we need for a movie. But as you can see, the left one has a JSON key annotation, because inside the JSON, the name of the key is different than what I want to use as the variable name. It has a underscore. And this is information that's only necessary or interesting to the API area, nowhere else. So this is not some information we should provide to the upper components. So what we are doing is we are transforming this class to our normal data class, in this case movie, and this will then be provided to the upper layers. The same example you could also have, for example, at the database. There I would have a class movie entity, and inside there, for example, the ID class field would have an annotation with a primary key. But this information is only interesting inside the database layer, so I would only have movie entity class there and would also map to the normal movie class before I provide it from the repository upwards. So that's just a little on the side note. So now we are transforming our list of movie DTOs to a normal list, and so we have that. Now we can return this. But as you can see, we are not directly returning this. We are wrapping this all inside a result class. That's a sealed class, in this case with two children, like result success and result error. Why are we doing this? So at first you can see we're all wrapping this inside a try-catch block. Of course, this could be done more in detail. It's just for demonstration. We want to make sure that nothing than just the data that's needed passes the repository to the upper components. Because if, for example, some exception would be flown to the upper components, that would be quite bad because these components don't know how to handle this. And these informations are also nothing they need. If you, for example, have some, network exception, then that's nothing that's related to the upper components. So first of all, we're making sure that nothing than the data we really want to pass to the upper components really passes. And aside from that, we are wrapping this all inside a result so we can state our different cases. Like for example, if we have our result success, then everything went fine, we can provide our list in there. But if something happened, like for example, we don't have, network access, we could return a result error, maybe with some result code or some message on what went wrong, and can provide this then to the upper layers. And then they can decide what to display based on this information to the user. So to summarize now all up, what the repository is doing, we can see on the bottom right again, we have our list of movie DTOs, we get them inside the repository, convert them to a list of movies and wrap them inside a result. And this is what the repository is providing to the upper components. So now let's head on to the next component, and this is our stakeholder. And as you can see here, I'm also using the BLoc library, in this case just the Cubit, because it's more easy for this example. But I don't will go too much into detail since we already had an awesome talk about BLoc. So just in short, at every time we are emitting some state to the UI, which you can listen to and then update itself. So inside this stakeholder, or this Cubit, so to say, we again have our dependency, in this case our repository, and again dependency injection will take care on how to instantiate this repository and pass it into the Cubit, and here we can now use this. And what are we doing then? Well, at first we are getting our list of movies, and then based off the result, like let's say it was a success, we are then just adding these new list of 20 movie elements to our already existing list. Of course, in the beginning, this already existing one is empty, but afterwards, if we load more and more pages, then we want to add even more movies, and then we get 20, 40, 60, and so on. So we're just adding the one we had just loaded. And then we can emit our Cubit state and show this to the UI, that everything was nice and right, and that's pretty much it. So to summarize this, we get in the bottom right again, we get from our repository our result, and we transform this to our UI state. Inside the UI state is everything the UI needs. Can of course also be a little bit more than just the data. For example, if you have an input form inside your UI, you maybe want to store this also every time in your stakeholder, then you could also adjust this to your UI state as you wish. And that's it for the stakeholder. So now we can jump to our UI elements, and here you see pretty much normal screen. We have our stateless widget, and now the question is, what are we doing here? So at first, of course, we have our block builder. We've also seen this in the previous talk. We're listening here to the state of the qubits, and based on the state, we're building our UI. So let's say everything went nice and right. What are we doing then? As you can see, we are calling another widget, and there we are providing all the data it needs, like the movies, and also some lambdas for some events having as click callbacks. Pretty much not more to it. So to summarize it again, on the right side we have our UI state, and we provide this to the UI. That's pretty much it. Maybe have a little look inside this popular movie content child widget, because as you can see, again, it's a stateless widget, so not much to it, but interesting is more what parameters it takes. As you can see, it doesn't take the state of the qubit directly, or even the qubit itself. It's just taking a list of movies and two lambdas, which should be called when something is happening. I forgot to say, when we reach the end of our list, then we want to load the next page, like loading the next 20 elements. That was, I forgot to say, that's the lower callback on list end reached. Then we want to load our next chunk of movies. So interesting here, just the list of movies and some lambda callbacks. No qubit, no state, no whatsoever. And this may be a little bit in contrary to the previous talk. So what we are doing here, we move the state as much up as possible, pretty much in our previous screen, the screen which is the parent of this popular movie content. And then we pass down only the data this widget and all the child widget need. What is the benefit of this? This widget and all its child widget are completely agnostic of the stakeholder that we use. We can reuse this widget in any other screen we want. If we would, in this widget or in some child widget, also listen to this specific qubit that we just had, then they would be dependent on this qubit. And if I want to use this widget in some other screen, and I think, oh, that's super nice, it's all the UI I need, I want to use it, and then in the other screen I notice, oh, I have to use this block, I have to fill its data and use it, but I can't really do this, then I'm completely dependent on this. So I can't really reuse this component, but with this way I can do this. So we are moving the state as much up as possible and only to the children, providing the data they need and the Lambda callbacks. And this procedure is actually called state hoisting, like moving the state as much up as possible, only providing data and the Lambdas to the children. Now, we can head back to our parent widget. And now, as you can also see on the arrows to the right, we have pretty much passed our data to the UI. The UI is displaying it, and there's pretty much now not much to it until some event is triggered. Like we click on a movie element, or like, for example, we reach the bottom of the screen. And now the question is, what is happening now when some event is triggered? And as we can see, when we reach the end of the list, then we are calling our qubit and calling a function in there to state to the qubit that, hey, an event has been triggered, like we want to load more movies. So now how is this happening? So on the right, we can see the event has been created by some user input, and now we pass this event to the stakeholder. And now the question is, what is the stakeholder doing? And you may have guessed it, inside our qubit, we're just calling the repository to get the next chunk of movies. We're just increasing the page, and then we load the next list of movies. And what is then the repository doing? Well, it's just calling the API, which itself then will get the list of movies, return them in the end, and then we can display it again. So if we look on the right again, we can see we are passing this event pretty much down to the data source. The data source will manage on how to get these new movie list elements, and then it will pass them again to the UI all the way back. And as you may have seen, this is pretty much now our circle on how data and events are flown. And that's also a good keyword here, because if we are now having a detailed look on how this all is flowing, we can see our data is flowing in one direction and the events are flowing in the other direction. And this is actually called the Unidirectional Dataflow. So we have one circle in one direction, and the data and the events are following this circle, like data from data sources to UI elements, and the events from the UI elements then back to the data sources. And bear with me, just for that, Google turns around the whole thing. Don't worry, everything is still in place. It's just that the data sources are now on top and the UI elements are at the bottom, because they say the state goes down and the events are going up. And that's why just here they're turning around the architecture. It's a little bit annoying, I don't know why. But just for that, they're turning it around. Don't worry, everything stayed the same, and we can just switch it back as it was before. So that's for the basic communication, just as an example. There are some variations here. Like for example, as we can see, we have here a dotted arrow, and here we have a solid arrow. The question is, why is that the case? Well, the dotted one, there we have the case that the stakeholder, in this case the qubit, it has a stream. When it has a new state, it puts the state inside the stream, then anyone who wants can listen to that. In our case, it's the UI. But the UI can just listen to the stream, and whenever there's something new, it can take this new element and display it. So the UI doesn't have to poll the qubit every, 5 seconds, like, do you have something new, do you have something new, and so on. It just listens to the stream, and that's it. as we have seen inside our repository, we just have a function that returns then something. Like we want to get a list of movies, and we get a future that has inside itself the result with the list of movies. So the function directly returns something. But there are some scenarios where also the Cubit would like to listen to some data, and every time something changes within the respective repository, it wants to get these updates. For example, let's take our list of movies inside the app I've shown you previously. If we click on one element, then we would go into some sort of detail page. And let's assume in this detail page we show more information about this movie, and there would also be an option to alter the data of this movie, like having a little dialogue where we can, for example, adjust some typos or add a user-based rating, for example. And if we would change this data via the dialogue, then it would be changed inside the data source, but then we would close the dialogue, and the actual detail screen should also directly show these updated values. So now the question is, how could we do this? Like in the end, we also want to have a dotted line here. So let's see, how can we do this? Yeah. So here we can see a repository for movie details, just a data type I described. What do we have here? We have now two dependency, like one API and one database. Here I use Flutter as a technology for database. And what are we now doing inside this repository? We have again a function to get a specific movie details based on the ID of the movie. So what are we doing now? In the first part, we are going to our database and check if this movie detail already exists locally. If that's not the case, then we go to our API, get it, and then store it locally. Because for this movie detail, it makes sense to store it in a database, because if you go inside the movie details, then back to the list, then again in the movie details, then we don't want to load them again from the network, we want them to cache locally, so it's not too much of a heads up. So that's why we are then storing it inside the database. And in the end, we always return a stream that listens to this entry inside the database. And now some stakeholder, some Cubit for example, can listen to this stream that the repository is providing inside the result. And if something is changing inside the database about this specific movie detail, then it will automatically be updated, because this stream listens to the record inside the database. So if anything changes, we directly get the changes inside the Cubit. We can update our UI state and directly show in the UI what we want to show here. So that as a little variation. So now there is another thing I have spoken previously very shortly in the first section, and this is actually the domain layer. It's in between the data layer and the UI layer. And I said in the beginning, its main purpose is to reduce the code inside the repositories or the stakeholders to like extract it maybe. Maybe let's have a little example what we could do here. So here we have a class. It's a simple class with this super short name, get most rated movies and TV series use case. So that's nice. So what do we want to do here? We want to show a list of the top most rated movies and TV series. So two data types combined and show them in one screen. And here we of course then need two repositories, one that handles the movie type and one that handles the TV series type. And what are we doing then? Well, we are getting our data from both repositories. We are getting our list of TV series and list of popular movies. And if both of them went fine, let's just assume, then we just wrap them in another data class, in this case, most rated movies and TV series, and just return these then to whatever stakeholder needs it or wants to have this. And this could actually be now an actual use case inside our UI. That's also why I have the suffix in the class name, because that is something that could easily be needed by different qubits. And it could also be something that is reused as a code. And this is, for example, one of the classes inside the domain layer, like having code that is often used or that is describing some use case that could be used in multiple screens. And now one more interesting thing here. This is not just a simple function. What we're doing here is overriding the call operator. So if some stakeholder is using this class, then what it's doing is like just having the class name and then the normal brackets, like calling it just like a lambda. What we are doing here is we're making sure that this class, this use case, only has one purpose, one function. And we don't have other functions inside this class. We're just overriding the call operator. And with this pattern, we are always want to make sure, like a paradigm, that we're only having one functionality inside each use case. That is an example also for the domain layer. And now, maybe as an overview, since you have seen a little bit about the app I was using, maybe giving you a little overview on what I've used inside this app, that you can also see how the components interact with each other. At the top, we have our different screens, like these are the widgets I've used and some of them also shown, like for example the movie details screen and the popular movie screen, and like when we click in one element in the popular movie screen, we go to the movie details screen, and also the most rated movies and TV series screen, super name. And as you can see, each of them has their own stakeholder, in this case a qubit, but of course we could just replace this library with any other, which is suitable for stakeholders. So here our qubit, each for one UI element. Then our domain layer, in this case, again, some simple use case, could of course be way more and have some other reused logic here. And then in the end, our data layer, where we have our repositories based on the data type we want to use. And then each repository uses the data source that it needs or that it wants to use, like our DAO to access the database, or like our APIs to get the respective data source. And that's all from my side. I hope next time when you have want to create some project, some Flutter app, then you have some guidelines on using an architecture. Of course, it's just a recommendation. And yeah, just have some architecture that is easily scalable, maintainable, and usable from the start. And yeah, I hope I could give you something to show. And that's all from my side. And if you have any questions, I'm happy to answer them.
Thank you, Adrian.